Hi guys, so let's continue with our program. So let's say now we want to multiply two matrices. Okay. Now see, we are not returning the matrices. The important concept over here is when we are calling the matrix, we are simply passing the name of the matrix. Whenever you are calling an array or whenever you are calling a matrix, you only pass the name of the array or the name of the matrix because the concept here is that the name of the array itself is the address of the array, whether it is 1D array, 2D array, whatever, or 3D array. What will be a 3D array? Just like array of numbers was 1D array, array of arrays was 2D array. So if we create an array of 2D arrays, that is array of matrices, it will be a 3D array. So whichever dimension array it is, when you pass the name of the array, that itself is the address of the array. So now here implicitly we are using call by address or call by reference. Basically here we are passing the address of the matrix or our 2D array. Therefore, whatever changes take place over here, we are taking the input in this function, right? We are using cin over here. But whatever changes take place over here are also reflected over here because it is call by address or call by reference. The function is working directly at the address which is passed by main method. Main method calls matrix input and it passes matrix to rows and columns. So whatever changes takes place, whether it is taking input or now as we'll see multiplication, it takes place directly at the address of the matrix. Okay, so let's go ahead and write the function. So my point was that's why you don't need to return anything. You don't actually need to return a 2D array. You can keep the return type as void and rest assured that the changes whatever you are doing here will be reflected in the uh, calling method, that is main in this case. Now there is another thing. When you're just reading the matrix, you don't want the function which is reading it, which is main in this case, you don't want it to make any changes accidentally or on purpose. So you declare this as const. This means matrix output method can only read the matrix or read the 2D array, but it cannot make any changes to any element. It can only print, it can only see out. It cannot see in, it cannot add or subtract or do any changes to any element. It cannot. Okay. So because we have declared it at const. If a function is defined to just print the 2D array, it does not need to have access to change the elements within the array. It only is supposed to print it. Right? So makes sense to make it const when you are passing the matrix over here. Coming back to matrix multiplication, here what we'll focus on is there are two matrices, int matrix, let's call it matrix 1, and again we'll have to specify the columns. We can continue it on new line, no problem. It's not like the entire argument list or parameter list has to be written on the same single line. There is no such rule. So then we'll continue it for ease of readability. Matrix 1 and matrix 2. Now because you're passing matrix 1 and matrix 2, you will also need their dimensions. So let's say rows 1, rows 2, then sorry, rows 1 and columns 1, right? Rows 1 and columns 1. And for matrix 2, similarly, you have rows 2 and columns 2. And because we are not returning the result, we will also have int result, which will also be a matrix. So in main method itself, we will have to pass one more matrix as a parameter over here, which will contain the result. Okay. So it's like we are supplying three matrices to the matrix multiplication method. Matrix multiplication method will take two of those matrices and multiply them and store the result in the result matrix, result 2D array. Right? Now, all of you know the conditions for matrix multiplication. Number of columns in the first matrix should be equal to number of rows in the second matrix. right? So I will do that check first. If columns 1 is not equal to rows 2, so that means see out, they are incompatible matrices, right? On the other hand, if the columns and rows match, then we will have to write a loop to calculate the product. So else में जाके we will create a loop. Now how will the loop be? So for example, if you say that, okay, of course. Now when you're writing this loop, think about the result matrix. Think like you are filling the result matrix. Okay. So what will be the number of rows in the result matrix? It will be equal to the number of rows in matrix 1. And what will be the columns? Number of columns will be equal to columns 2, right? So for I less than rows 1, I plus plus, and then inside it we have a nesting j equal to 0, j less than columns 2, j plus plus. Now in case of matrix multiplication, we have a concept that to actually calculate the product, we will need to multiply an element of one matrix. So basically the entire row. So for example, let's say if we are multiplying, okay, let's say you are multiplying 1, 2, let's say these are the two matrices that we have, 5, 6. So what will be the result? 1 will be multiplied with 3, 2 will be multiplied with 5, right? And the result will be added. So 1 into 3 is 3, 2 into 5 is 10. So the result will be, of course, 13. Are you getting it? So how many times does this calculation takes place? This is equal to the number of columns in the first matrix, or you can say number of rows in the second matrix. So which is a common number that we will take, okay? And for each row, we have to take the sum. So what we will do is, here we will initialize a sum variable. Okay, so int sum equal to 0. And now you will simply say sum, okay, sum equal to 0. Now you will have to create a for loop again. This is because 1 has to be multiplied with 3. Then continue with the loop, 2 has to be multiplied with 5. Got it? Can either take columns 1 or rows 2, whatever. K plus plus. And you will say sum plus equal to matrix 1 of ik into matrix 2 का kj. Okay, and once you calculate the sum, so loop will execute only this much. This is the loop. After the loop, what we will do is because it's a single statement inside a loop. There are no curly brackets, so there is only one statement. And after this, what we will do is we will say result of ij is equal to sum. Got it? Are all my brackets intact? This bracket does not have a closing. I'll just remove this example. I hope the concept was clear to you. Okay, enough of the bracket nuisance. Let's call that. Let's call matrix multiplication and let's pass the actual matrices that we have. The only thing that we'll need to create now is the result 2D array, right? That will have to pass over here. So let's say we create int result, and again first row you need not specify, but second one should be 5 just to match it. But here here what will be the number of columns in the result? Sorry, what will be the number of rows? It will be equal to rows 1. Okay, and after the okay, here I'll also write result, and after the entire thing I will again show the result matrix. I will show the result matrix basically. Over here I will display result is, instead of matrix 1 is, we will say result is result rows. It has rows 1 number of rows and columns 2 number of columns. Let's see how it works. Matrix rows columns matrix 2, and then the rows and columns in matrix 2, and then the result. I've passed everything. Oh, sorry, silly mistake. I did not specify the data type. Guys, okay, so this is okay. Here we don't, rows 1 was not declared in this scope. Oh, there is no rows 1, there is just rows. There's no rows 1. Okay, Result rows 1 and columns 2. There is no rows 1, it's just rows, right? So how many rows and columns? Let's say 2 by 2. Let's make it simple. Let's keep one of them as identity. E4, 1, 2, 3, 4, 1, 2, 3, 4. Got it? So that was for modularizing matrix multiplication. If you have any questions, any doubts, don't hesitate to put them in the comments below. Thanks for watching.